Hello, all. Welcome to the day 10 of the daily case study series for Cbse grade 12. Today's question goes like this: solar panels have to be installed carefully so that the tilt of the roof and the direction to the sun produce the largest possible electrical power in the solar panels. A surveyor uses his instrument to determine the coordinates of four corners of a roof where solar panels are to be mounted. In this picture, suppose the points are labeled counterclockwise from the roof corner nearest to the camera in units of meters. P1, P2, P3, P4 has been given. First question: what are the components of the two edge vectors defined by? A vector is position vector of P2 minus position vector of P1. To get the components of A vector, 21, 8, 4 minus 6, 8, 4, that is 15, 0, 0. The same way for B vector, position vector of P4, which is 6, 16 and 10, minus position vector of P1, that is 6, 8, 4, which gives us 0, 8, 6. So we have given the answer in the components form. Question 2. Write the vector in standard notation with I, j and k. So A vector will be equal to 15i plus 0j plus 0k. Same way, B vector is 0i plus 8j plus 6k. Question number 3. What are the magnitudes of the vector A and B and in what units? So magnitude of A is root 15 square plus 0 square plus 0 square, which gives us 15 meters. Magnitude of B vector is root of 0 square plus 8 square plus 6 square, which is 10 meters. Question number 4. What are the components of the vector n perpendicular to A and B and the surface of the roof? We need to generate the cross product of A and B. N vector is equal to A vector cross B vector, that is ijk, and let's take 15, 0, 0 and 0, 8, 6. Get the determinant value for this. I times 0 minus 0 minus j times 15 times 6 minus 0 plus k times 15 times 8 minus 0, which is the I component is 0, j is minus 90. So it's minus 90j plus 120k. Components are minus 90, 120. Question number 5. What is the magnitude of n and its units? Magnitude of n vector is equal to square root of minus 90 square plus 120 square, which is equal to 22,500 under root, and this is equal to 150. We very well know that the cross product of two vectors returns the area. So it is 150 meter square. The sun is located along the unit vector S If the flow of solar energy is given by the vector F, which is equal to 910 times S in units of watts per meter square, what is the dot product of F and N and the units of this quantity? The question says F vector is 910 times S vector. S vector is half I minus 6 by 7 times J plus 1 by 7 times K, which is 455 I minus 780 J plus 130 K. So we get this by multiplying 910 with all the components. F dot N is equal to F is 455 I minus 780 J plus 130 K dot N is minus 90 J plus 120 K. 455 into 0 plus minus 780 into minus 90 plus 130 into 120. On calculating this, we get 85800. This is in watts. Question number 6. What is the angle between the vectors n and s? N vector dot s vector is equal to magnitude of n, magnitude of s, and cos theta. That is the angle between n and s. Magnitude of s vector is root of half square plus minus 6 by 7 square plus 1 by 7 square, which is equal to 49 plus 148 by 196, which will be root 197 by 196. So this is approximately equal to 1. Now the angle between n and s. Now we know what is n, what is s, magnitude of n, magnitude of s. So let's get the cos theta, that is dot product of n and s by magnitude of n, magnitude of s. N is minus 90j plus 120k dot half I minus 6 by 7 times j plus 1 by 7 times k by n's magnitude is 150 and s we got it as 1 approx value. On multiplying this, minus 90 times minus 6 by 7 plus 120 times 1 by 7 by 150, which is 660 by 150, and that's 7 is there into 7. This is equal to 0.629. That is theta is equal to cos inverse of 0.629. The question has given us the value for cos 51 degree, which is equal to 0.629. So the theta is 51 degree. Theta is equal to 51 is the angle between n and s. Suppose this is the surface of the roof and n vector is perpendicular to the roof. Now what we have got as 51 is the angle between N and S. Say this angle. So to get the remaining angle, that is between the sun's rays and the roof surface, these two are complementary angles. So if we subtract 51 degree from 90, we get 39 degree. The angle of elevation of sun above roof is equal to 90 minus 51, which is equal to 39. Let's meet tomorrow with another case study question. Thank you all.